Okay, here we're going to look at testing or comparing two means using an example of GPAs. So we have a two-sample test statistic. Okay, so it just means that we're comparing two groups to each other. So we have two samples that we're collecting, and we're going to calculate the test statistic. Okay, so when sigma is unknown, we're going to use the t-distribution. Now, if you remember, when we did hypothesis tests for one sample, remember that the t-test statistic was x bar minus mu divided by s over the square root of n. Okay, that was when you had one sample. Well, now that we have two samples, we have to bring that second sample into it. Okay, so the concept will still be the same, except now, instead of just x bar minus mu, now you're taking the difference in two sample means. So the first sample mean minus the second sample mean, and then you're going to subtract, instead of just mu, you're going to subtract mu1 minus mu2. And then instead of dividing just by s over the square root of n, we're dividing by the first sample standard deviation squared divided by the size of the first sample, plus the second standard deviation squared divided by the second sample size. Now that compares to the one sample test statistic, because if you take just one sample, so if you took s squared over n, when you actually square root that, the square root of s squared is s, and then square root of n on the bottom will be like that. Okay, so you can see how that's the same concept, it's just that we have to bring this other standard deviation or other group into it. Okay, that second group. Okay, so that formula looks really confusing, but believe me, you're just going to look at two different samples and then plug and chug into the formula here. Okay, confidence interval for mu1 minus mu2. So now we're looking at the difference in means. You take the difference in the sample means. So our best estimate for the difference in population means is the difference in sample means. Okay, then you add or subtract your t star, because sigma is unknown, so we're using t, and then multiply it by that square root again that we had up here. Okay, so this first example we do will make those formulas look a little easier. Okay, suppose a social scientist claims the mean GPA of students who use a certain social media site is less than the GPA of students who do not use that social media site. Suppose the following sample data is collected. So students who use the site have this sample data. 128 students were asked. Those who use the site, there's 128 of them. And these are their sample mean and standard deviation from that sample. And then a sample of 85 students who do not use the site had a mean GPA of 3.25 and a standard deviation of 0.42. Now I will point out that with these comparing two means, these are independent of each other. Okay, so each of these groups is independent of each other. So basically saying you either use the site or you don't, so there is no overlap in answers. Okay, so an individual could not belong in each sample. They're either in one or the other. Okay, so to construct a 95% confidence interval for the difference in population mean GPAs of students who use the site and those who don't use the site, well, we have to look at what it's asking us to do, because now we're adding on to the one sample confidence intervals hypothesis test. So now we have to really pay more attention to what are we constructing a confidence interval for. It's the difference in population mean GPAs. So difference in population means is this, mu1 minus mu2. Okay, in the past, I could have just asked you, construct a 95% confidence interval for the mean GPA of all students who use the site. Then you're only looking at these students who use the site, and you can construct a confidence interval trying to estimate the population mean GPA for those who use the site. Same idea for if they do not use the site. Okay, so there's a lot of different types of questions you can be asked, and it's up to you to know which formula to use or which concept is being applied here. Okay, so to construct that confidence interval. I have it done out here because there's a lot of writing. We're going to use the formula up here. Okay, so we're going to take the difference in the sample means, 2.97 minus 3.25. So my first group is those who use the site. My second group is those who do not use the site. Okay, so you subtract those. And then the t star value, we use the smallest degree of freedom. Okay, so up in the directives here, the smaller degrees of freedom, our sample sizes were 128 and 85. So the smaller degrees of freedom will be 84. Okay, so that's n minus 1 will be 84. Okay, so that's where the 1.99 comes from. And then multiply it by the square root, that first standard deviation squared over the first sample size, plus the second standard deviation squared over the second sample size. Okay, and if you examine the numbers and match up where they're coming from, that should be pretty self-explanatory. Okay, so then, the most annoying part of this is probably the substitution into your calculator. Okay, what I suggest you do is do that, what's under the square root first, and then multiply by 1.99. And I'll leave it up to you to actually do that and make sure that it matches up. You should get something very close to 0.172, depending on rounding. What I suggest you don't do is don't do 0.83 squared and then round that, and then divide by 128. Put that entire expression that's under the square root, put that all in there at once. Okay, what you want to round is this number here, the margin of error. That's what you can round. Okay, so we get negative 0.28. Okay, and that negative in the first part here is just telling us that we had a smaller number minus a larger number. Okay, so the sample mean for those that use the site is smaller than the sample mean that don't use the site. Okay, so when you do the calculations there, our interval gives us two negative numbers here in our interval, and this is the other way to write that. We're 95% confident that the difference in population mean GPAs is between these two numbers. Okay, now one thing I'll bring up now that I didn't ask is we can look at that and say, well, whoop-de-doo, we have a confidence interval. So what does it mean? Well, when you subtract the means, mu1 minus mu2, you're taking those who use the site minus those that don't use the site. If we're expecting to get a negative answer for that, okay, so we're expecting on average to get a negative answer. So what that means is when you subtract two numbers, how do you get a negative answer? You had a smaller number minus a larger. So that's implying, because these are both negative, that's implying that those who use the site had a smaller GPA than those who did not use the site. Suppose that they were both positive. So just suppose we had just two positive numbers here, whatever they were, they're both positive. What that would mean is when you subtracted, you had a larger number minus a smaller. That would imply on average, those who use the site is larger than those who do not use the site. Okay, so that's if they were both positive. Well, the only other option is for them to have opposite signs. So either both negative or both positive or opposite signs. Opposite signs means that 0 is in your interval. So if you go from a negative to a positive, 0 is in between them. So if 0 is in your interval, that implies that there could be no difference in the means. That would imply that mu1 minus mu2 could have been 0. So that would imply no difference in the means. So again, what this interval is telling us, it appears those who use the social media site have a smaller GPA on average than those who do not use a social media site. Okay, next part is looking at testing a claim with alpha's 0.05 that the mean GPA of students who use the site is less than the mean GPA of those who do not use the site. So again, just like in that first one, we were looking at the difference in population means. Now we're comparing the mean GPA of the users being less than the mean GPA of the non-users. Well, it's a hypothesis test because we're testing the claim, so we need to set up hypotheses. So the mean of users is less than the mean of non-users. So mean of the users, so mu1 less than mu2. The null hypothesis always says the equals, so that's mu1 equals mu2. Okay, so this is different than all the other ones we've done before, because before, when we only had one sample, we would have had something like mu1 equals 3.2, or mu1 equals 2.7. Okay, so now we're comparing means rather than one mean to just a number. Okay, so you need to recognize that difference. Okay, and what I have written in red there is another way you can write those hypotheses. If you subtract mu2 on each of these, the null and alternative hypotheses, mu1 minus mu2 equals 0. Okay, that would be another way to write the null hypotheses. The alternative, if you subtract mu2, you'd have mu1 minus mu2 is less than 0. That's another way to write the alternative. And that's kind of what happened up here. Mu1 minus mu2 less than 0. Here we have negative endpoints in our interval, which would kind of be going along with this idea here, that mu1 minus mu2 is less than 0. Okay, so once we create our hypotheses, we create a rejection region. So our rejection region for HO. Okay, so we have our t distribution. We have alpha's 0.05 with 84 degrees of freedom, because that's n minus 1 in the smaller sample size, and you get negative 1.664. Okay, and again, I'm assuming that you can find those values. Now, if you can't use the t distribution, go back to the videos that show you how to find them. After our rejection region is set up, now we look at our data, calculate our test statistic, and then make our decision. Okay, so we're using 2.97 minus 3.25. That's x bar 1 minus x bar 2. Now notice here it's minus 0. And that's why I brought this up right here. The formula has mu1 minus mu2. Well, much of the time, if your null hypothesis is that they're equal to each other, if you write it this way, mu1 minus mu2 is going to equal 0. Okay, now, it doesn't have to be 0, and I'm just going to go off on a small tangent here. It doesn't have to be 0 here. It could be worded such that the mean GPA of students who use the site is less than 5 of the mean GPA of students who do not use the site. So they might say that mu1 minus mu2 is less than 5, or mu1 minus mu2 is less than 0.2. Okay, so you have to pay attention to the wording, but much of the time that'll be mu1 minus mu2 equals 0. Okay, so the test statistic here gives us a t-value of negative 3.242. Okay, and make sure that you get that on your calculator. And that test statistic is going to be out here to the left of the critical number for t star. Okay, so if the means really were equal to each other, then getting this difference, okay, 2.97 minus 3.25, so that negative 0.28 difference, that would have been unusual if the means really were equal to each other. Okay, so our decision is to reject HO, which means there's enough evidence to support the claim that the mean of the users is less than the mean of the non-users. Okay, and I just want to do this last one here to really point out the difference in comparing two means rather than just using one mean. Test a claim with alpha equals 0.05 that the mean GPA of students who use the site is less than 3.1. So here when we read this one, it says nothing about those who do not use the site. So now we're back to just looking at one sample, those who use the site. Okay, so your hypotheses here would be that the mean is less than 3.1. and the null will be mu equals 3.1. Okay, so this goes back to the last chapters where now it's only one sample. Okay, so you create your rejection region again, and then calculate your test statistic. And remember, this test statistic is easier. X bar minus mu divided by S over square root of n. Okay, and then your test statistic is negative 1.772, which is in this rejection region to the left of negative 1.66. Okay, and what that means, you reject HO, and there's enough evidence to support the claim that mu is less than 3.1. Okay, so that's just how you, when you read the question, now you really need to focus on which formula you're using and which content it's actually asking you for. Okay, so this last one was using one sample compared to two samples up here.